All right, welcome to Unit 5, Day 3, where we're going to talk about symmetry of graphs and transformations. All right, so let's take a look at our first function that we're going to look at is something called an even function. So an even function has y-axis symmetry. And y-axis symmetry, all that means is if I fold my graph, so for an example I have right here, if I take my graph and I fold it along the y-axis, the two pieces will be directly on top of each other. Okay, so take a piece of paper, draw something like this, fold it along the y-axis. That means it has even symmetry. Okay, now not every single solitary time do we want to graph it, fold it along the y-axis to see if it has even symmetry. So there's a way to do this algebraically. Algebraically, this means that f of negative x equals f of x. And you might be thinking, like, what exactly does that mean? So let's just think about this for a second. All right, so let's think about some ordered pairs that we would have on here that would show that this is symmetric about the y-axis, okay? All right, so let's just start out with this ordered pair right here. Let's just say this has the ordered pair of 2, 3. Okay, and then over here, remember this would have to have the exact same height. So this ordered pair would be -2, 3. Those y values have to be exactly the same. So if we take a look at this, 2 maps to 3, so 2 goes to 3, and -2 also goes to 3. So what this is saying is that when I plug in x, and when I plug in negative x, so if x is equal to 2, negative x would be -2, then your outputs or your y values are exactly the same. So f of x, remember, is the same thing as y. So when I plug in x, f of x, I get 3 back out. When I plug in the opposite, or f of negative x, I also get 3 back out. So this right here, f of negative x equals f of x, is just saying when you plug in both x and you plug in negative x, you get the same y value back out. Okay. All right. So we're going to show you how to do this algebraically. So what you're going to do is you're basically going to take your original function. You're going to plug in negative x everywhere you see x in the original function. If you end up with the exact same function, then the function is even, because that's like saying if I plug in 2 and -2, I get the same y values. You plug in x and negative x, you're getting the exact same function back out. All right, so let's just take a look at this graph. All right, number one, a function is even if it's symmetric to the y-axis. So right here, I could take this graph, I could fold it in half, and I would get the exact same, they would be on top of each other. Let's also just take a look right here with an ordered pair. This is 1, 1. Okay, this is -1, 1. F of x, so this is when I plug in 1, and f of negative x, when I plug in negative x, notice I get the exact same y values back out. All right, so let me show you what this is going to look like. All right, so I'm going to plug in negative x for x. Okay, so everywhere I see an x, I'm going to plug in negative x. So this is going to look like f of negative x. The -3 stays the same. Anywhere you have exponents, make sure you put parentheses around them. Negative x squared plus 4. Okay, so then we want to simplify this. Now, this -3 stays. Remember, negative x squared is the same as negative x times negative x, and that's actually going to give me a positive x. Okay, so that becomes positive x squared plus 4. All right, now let's actually take a second and compare these. Our original function was -3x squared plus 4. Our new function, when I plugged in negative x, is also -3x squared plus 4. So this function is even because f of x equals f of negative x. All right, and you must have this concluding sentence. You must state it's even and then y. And let's just look here, okay? F of x is -3x plus 4. When I plugged in negative x, I also get -3x plus 4. All right, so we're good to go. So that's an even function. All right, now the next question is, well, what exactly is an odd function? Looks different. I'm just kidding. All right, so an odd function is something that's called symmetric about the origin. All right, so basically, if you were to rotate the entire graph 180 degrees about the origin, or basically if you reflect it over both the x and the y-axis, okay, then it's going to be symmetric about the origin. So what this is saying is opposite x values give opposite y values. So remember, if it was even, okay, when you plugged in an opposite x, you got the same y. What this means, okay, f of negative x equals negative f of x. That's kind of confusing. What that means is, let's just say I had the ordered pair 1, 2. Now, this is x, this is f of x. Negative x, so when I plug in -1, I should get, notice my y value is not going to be the same. My y value is also going to be opposite. So I should get -1, -2. Okay, so what you're going to do for this to check algebraically, you're going to plug in negative x for x the same way you did with an even function. If the resulting function has every single solitary sign that's the opposite, then it's odd. So just think, if you took the original function, multiplied every single solitary thing by -1, then it's going to be odd. All right, so let's just take a look at this example. And I'm going to pick a point on the graph to kind of show you how this works. All right, so we have this point right here. This is 1, -2. Odd would mean that when I plug in the opposite, okay, so when I plug in -1, I should get the opposite back out, which is +2. And if I look, -1, +2 is also on my graph. So basically, if you were to take this graph and rotate it 180 degrees, so I know that's kind of hard to see, but like literally think of taking it and rotating it 180 degrees. This graph would look exactly the same. So basically this point right here would all go to right here, and these points right here would all go up here. So you could take a piece of paper and try that. But let's just see what this looks like algebraically. All right, so we want to determine if this function is odd. So where everywhere I see an x, I'm going to plug in a negative x. So this is going to look like f of negative x is 2 times negative x to the third. Always make sure you put your exponents in parentheses, equals -4 times negative x. All right, now we want to simplify it. Okay, negative x to the third, remember, is negative x times negative x times negative x, which is really negative x, 2 negatives make a positive. You have 1 negative left, negative x to the third. So that is going to make this entire piece negative. And you have -4 times negative x, which makes it positive. All right, now let's check to see how it compares. My original function was 2x to the third minus 4x squared. My function when I plugged in negative x was -2x to the third plus 4x squared. You have to check every single solitary sign. This was a plus, this is a minus, it's the opposite. This is a minus, this is a plus, it's the opposite. You must have this concluding sentence, all right? So the answer is odd. You must state f of negative x, okay, equals negative f of x. You will not get credit if you don't have this concluding sentence at the bottom right here, okay? So f of negative x equals negative f of x. It's basically just saying when I plugged in negative x, I got the opposite, every single solitary sign changed. All right, so I want you to take a minute and I would like you to pause the recording. I would like you to try all of these questions right here and just to determine if they're even or odd. So you're going to try this entire page with your partners, okay? And then once you've tried the page with your partners, I want you to hit play in order to get the explanations. Okay, so let's take a minute and go over the answers here. All right, so for this one, you're going to plug in negative x. So when you plugged in negative x, you should have gotten -2x squared minus 3x squared plus 4x plus 4. Let's compare. So we had a positive, negative, 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 we got all kind of stuff going on here. So it didn't all remain the same and it didn't all change, okay? So this one is going to be neither. It is neither even or odd. Okay. All right. So let's take a look at this one. With a graph, I would choose an ordered pair. All right. So let's pick an ordered pair right here. Okay. So this one, let's try 1, -1. Remember, if it's even, when I plug in -1, I should get the same thing back out. That would make it even. If it's odd, when I plug in -1, I should get the opposite back out. That would make it odd. All right, so we already said it's not even, okay, because -1 is not on my graph. Okay, then let's try -1, 1, -1, 1. Okay, that looks like it's really close to my graph, but it's not actually on my graph, so it's not odd. So this case, this one is going to be neither. All right, so let's take a look at letter C. So letter C, when you plugged in -x, you should have noticed that all the signs stayed the same. So we have positive, positive, I lied. One of the signs changed. So these stayed the same. We have positive, positive, and this was a negative, and this was a positive. So we had some change and some stay the same. So that is going to be neither. So they all have to be the opposite, or they all have to be the same. This one right here, we plugged in -x. You should have gotten -3x back out. Those are the opposite signs. So this one is going to be odd, but make sure you state because in this case, all right, you're going to have, use the correct symbols here. Y of -x is equal to -y of x, okay? And remember what that's saying is, when I plugged in -x, every single solitary sign change, it's basically like multiplying it by -1, okay? All right, so this one right here, let's take a look here. So negative, that became the opposite. This one stayed the same, so this one is neither also. All right, now this one right here, if you'll notice, this one is actually not a polynomial, okay, because it has a fraction, it has a negative exponent. Remember, 1 over x is the same thing as x to the -1, which would make this not a polynomial. But this is going to be okay. It can still be even or odd. All right, now if we notice, let's take a look at our signs, okay, opposite, opposite, so positive to negative, positive to negative. So this one is going to be odd. Okay, make sure you write your concluding sentence using the correct letters. So P of x is equal to negative P of x. Every single sign changed or became the opposite. All right, let's take a look at our last one down here. So this one right here, we have a positive and a positive, a negative and a negative. So this one right here was going to be even. Make sure you write f of x, f of -x, sorry, equals f of x. That negative is kind of hard to see right here. And then I apologize, I forgot to put the negative up here. So P of -x equals negative P of x, okay? So it's saying when you plug in the negative, what do you get back out? And I don't know if anybody kind of noticed anything here, but in order for the function to be even, you have to have all even exponents. Okay, I don't know if anybody noticed that. You have to have all even exponents and a constant, like a number added or subtracted. If it's odd, you actually have to have all odd exponents, okay? Because if not, the sign can't change. If you didn't notice that, don't worry about it. I just kind of wanted to show you that. All right, so your extra practice at the bottom. What I would like you to do for this one is I would like you to try this one with using a calculator only 2 times, okay? So, and those 2 times would be for the m of -8 and the m of 0.5. All right, I apologize, this moved a little bit, so let me kind of fix these. Okay, or actually, since I gave you these 3 answers, I want you to think about how you could use this not using a calculator at all. Well, number 1, hopefully what you noticed here is that this is actually an odd function. When I plug in -x, I end up getting -x to the 3rd minus a -x, which becomes positive. So this function is actually going to be odd. So that means whatever value of x I plug in, if I get the opposite, Okay, so remember, if you plug in your value of x, you're going to get the opposite back out. So negative x gives you negative f of x. So if this was 2 and this was negative 2, this would be negative 6. This is negative 504, positive 504, negative 0.375, positive